and let's see what it says. It says equilibrium is established in a system when the rate, very importantly, we're now coming back to these things of rates, of the forward and the reverse reactions are equal. Oh my word, what does that mean? Okay, so let's look at that. Let's just say I've got, my word, sorry, I need to switch to a pen over there. I've got A plus B, and that gives me AB, right? And now let's just say that the reaction is reversible, which if it is, I represent with a double arrow. Okay, so this particularly tells me that I've got a forward reaction which is A plus B giving me AB, and I've got a reverse reaction which is AB giving me A plus B. Now, the definition, if we look at chemical equilibrium, it says when the rate of the forward reaction, apologies for that, when the rate of the forward reaction equals the rate of the reverse reaction. Now, what is a rate? A rate is how quickly the products are made or how quickly the reactants are used up. Okay, so if I put this down and I say the rate of the forward reaction, right, is really how quickly we make AB. Okay, and if I talk about the rate of the reverse reaction, that's really how quickly AB breaks down to make A plus B. Okay, how quickly we make A plus B. How quickly AB breaks down to make this. Now, the thing is, when we establish something called equilibrium, right, it is going to be a case in which we find that A plus B are rushing to make AB, and AB, as they make AB, it breaks down to form A plus B. So if we take the ammonia example, you have nitrogen and you have hydrogen, and they come together and they form ammonia. If equilibrium is established in the system, the moment they make ammonia is the moment they break down and they form A plus B. So in essence, what we're trying to say is when a system approaches equilibrium, is that, let's just say at equilibrium, our substituents are not very useful, right? Substituents in the system are not very useful because the moment nitrogen and hydrogen come together, they break down and they form nitrogen and hydrogen again. And we will look at a number of properties of equilibrium, but for now we just need to understand that equilibrium occurs in a closed system, number one, and it happens when the rate of the forward reaction equals the rate of the reverse reaction. So I'm just going to clear this quickly. Okay, now we say dynamic equilibrium is simply equilibrium that is dynamic. Oh my word. So dynamic equilibrium is established when the rate of the forward reaction equals the rate of the reverse reaction, and both reactions take place simultaneously and continuously. Okay, now we will talk about how to manipulate an equilibrium, and it says over here there are, however, a number of factors that can change the chemical equilibrium of a reaction. This is basically saying is you can disturb the equilibrium, and we will deal with that in much detail later on. For now, remember the definition of equilibrium, dynamic equilibrium, and the three factors that can change an equilibrium. It's the concentration, it's the temperature of the system, and also the pressure. We will talk about each of those in more detail later on.